For most of human history, our solar system felt like a self-contained bubble. We studied our sun, planets, and comets, all born from the same ancient cloud. The space between stars seemed like an uncrossable ocean. The idea of something from another star system arriving here was pure science fiction. But the universe is more connected than we imagined. Our solar system isn't a fortress, it's a busy port, and sometimes visitors from distant stars sail through. These interstellar objects are messengers, carrying secrets from their home systems. When one enters our cosmic backyard, it's a monumental event, a rare glimpse beyond our familiar shores. Each discovery reminds us we're part of a galactic community, expanding our perspective and inspiring wonder. These aren't just new rocks in space, they're physical samples from other worlds, delivered by the galaxy itself. With every visitor, we unwrap another layer of the universe's mysteries, inching closer to understanding our cosmic origins. On October 19, 2017, astronomer Robert Warwick spotted a faint point of light with the Pan-STARRS telescope in Hawaii. At first, it seemed like just another asteroid or comet, but its speed, 58,000 miles per hour, meant it couldn't be from our solar system. It was on a hyperbolic trajectory, a mathematical signature of an interstellar origin. The object swooped in from the direction of Vega, past the sun, and sped back into the void. We named it ʻOumuamua, Hawaiian for scout from afar. Telescopes worldwide scrambled to observe it before it vanished. Its brightness varied dramatically, suggesting an extreme, elongated shape, like a cosmic cigar or pancake. Its reddish color hinted at long exposure to cosmic rays. But the real mystery, after passing the sun, ʻOumuamua accelerated slightly, with no visible outgassing or tail. It was a scout that looked and acted unlike anything we'd seen. No dust, no gas, just a silent, tumbling enigma. ʻOumuamua left us with more questions than answers. The universe had sent us a true cosmic mystery. So, what was ʻOumuamua? The debate was fierce. Some proposed it was a new kind of comet, outgassing invisible materials like hydrogen or nitrogen. Maybe it was a fragment from a Pluto-like world, with frozen nitrogen sublimating as it neared the sun. This could explain the acceleration without a visible tail. Others, like Avi Loeb, suggested something more radical. What if ʻOumuamua was artificial? A probe or solar sail from another civilization? Its shape and unexplained acceleration fit the idea of a thin, light object pushed by starlight. Most scientists favor a natural explanation, but the debate pushed us to rethink what's possible. ʻOumuamua forced us to question our assumptions about the cosmos. Whether a nitrogen iceberg or alien artifact, it proved the universe is full of surprises. Sometimes the questions are as important as the answers. Then, in August 2019, amateur astronomer Gennady Borisov discovered another interstellar visitor. 2I/Borisov's hyperbolic path confirmed its origin beyond our solar system. Unlike ʻOumuamua, Borisov looked and acted like a classic comet complete with a coma and tail. For the first time, astronomers could analyze the chemistry of an interstellar object's outgassing. Borisov's composition was familiar cyanide, diatomic carbon, and water just like comets from our own Oort cloud. This suggested the building blocks for comets, and maybe life, are common across the galaxy. But Borisov had a twist: an unusually high concentration of carbon monoxide. This hinted it formed in a much colder carbon monoxide-rich region than our comets. Borisov was both familiar and exotic, a tangible piece of another stellar neighborhood. Its discovery showed interstellar visitors might be more common than we thought. Each one adds a new chapter to our understanding of planetary systems. The universe had sent us a more cooperative messenger, and we were ready to listen. The parade continued in May 2025, when the Atlas survey in Hawaii spotted C2025N1 Atlas on an interstellar path. This time, we caught the visitor early, giving astronomers precious time to observe. C2025N1 Atlas was a hybrid, cometary like Borisov, but with erratic, explosive outbursts of gas and dust. Its wild behavior suggested volatile ices erupting after eons in deep freeze. Spectroscopy revealed a surprise. It was rich in heavy noble gases like argon and xenon, rare in our comets. This pointed to an origin in an extremely cold, distant region around a faint star. Atlas expanded our view of the diversity of planetary nurseries. If ʻOumuamua was the oddball and Borisov the familiar cousin, Atlas was the exotic relative from a land of extreme cold. Each new visitor is a unique sample from across the galaxy. Together, they paint a richer, more complex picture of how solar systems form. The universe's diversity is greater than we ever imagined. Why do these interstellar objects matter? They're the only physical evidence we have from other star systems. For centuries, astronomy was about looking, not touching. These visitors are free samples from distant worlds, time capsules from other places and times. By studying their composition, we learn what materials build planets elsewhere. Are water and organics common? Are Earth-like planets rare or typical? These objects also reveal the chaotic youth of solar systems, giant planets flinging debris into the galaxy. By counting them, we refine our models of planet formation, and there's always the chance of finding something truly revolutionary, maybe even a probe from another civilization. The search for interstellar objects is part of the broader quest to understand our place in the universe. Each one is a clue in the cosmic puzzle. The stakes couldn't be higher. Studying interstellar objects is like listening to whispers from distant stars. Their chemical fingerprints reveal the conditions of their birthplaces. Borisov's high carbon monoxide content pointed to a frigid origin. Atlas's noble gases hinted at an even colder, more exotic nursery. Each object is a cosmic artifact, letting us reconstruct unseen worlds. They're like bricks handed to a historian. Each tells a story about its home. These samples help us test and refine our theories of planet formation. Until now, we only had our solar system as a model. Interstellar objects give us our first external data points, showing the diversity of planetary systems. They help answer the deepest question, are we alone? If these visitors carry water and organics, life's building blocks may be common across the galaxy. These silent messengers might carry the secret that the universe is primed for life. The discoveries of ʻOumuamua, Borisov, and Atlas have sparked a new era in astronomy. Now we're building better tools to catch more interstellar visitors. The Vera C. Rubin Observatory will soon scan the entire sky, likely finding dozens or hundreds of these objects. With more data, we'll move from anecdotes to real science cataloging the types, sizes, and origins of interstellar objects. But discovery is just the beginning. Missions like ESA's Comet Interceptor aim to ambush a visitor for close-up study. Future projects envision high-speed chases to orbit and analyze these cosmic travelers. The technological challenge is huge, but the payoff is immense. Imagine a Rosetta mission not to a local comet, but to an object from another star. For the first time, we could study an interstellar visitor up close. The next decade could bring humanity's first direct encounter with material from another solar system. The hunt is on. Each interstellar visitor does more than deliver data. It changes our perspective. For millennia, the stars felt distant and unreachable, but these objects prove the galaxy is a shared, dynamic space. We're not isolated, we're part of a vast, interconnected web. Studying these messengers connects us to the story of cosmic evolution from the Big Bang to the rise of life. The water in our oceans, the carbon in our bodies, maybe they came from ancient comets, just like these. Interstellar visitors are a key chapter in our cosmic story. The next time you look up, remember the universe is sending us messages. Each visitor challenges our assumptions and sparks our imagination. The cosmos is full of mystery and discovery, and the search has just begun. The sky is full of whispers from other stars, and we're finally learning how to listen.